Hello everyone, this is Tahira Mazumder from IT department, Akgec Engineering College. Today I'll be talking on OSI reference model, which comes under the subject computer networks with subject code KCS 603 under AKTU. To start with, first I'll talk about what exactly layered model concept is, and then I'll start with more details about OSI model. In case of layered model concept, what we do is that we break the entire problem domain into multiple smaller layers, and we break it down for the task of understanding our process, the very working methodology of how exactly communication happens over a network. And through this process, we actually have easier understanding of the communication process. This also helps in speeding up development. Changes in one layer does not affect how the other layers work. This is another advantage of going for abstract layer. When you are breaking a task into sub layers, let us say layer 1, layer 2, layer 3, and so on. We are layer 4, layer 5, and let us say this is an entire problem domain. When you are dividing into a number of layers, so our focus when you're working in such as a layer 2, for example, the other layers will not get affected. So this helps in modularity approach also, and this also helps to standardize protocols across different manufacturers, and it also allows different hardware and software to work together. So when this is an outcome of having a layered model approach towards computer networks, the outcome is having a OSI model. OSI model is basically a realization of the layered model concept in computer networks. So what exactly is OSI reference model? I'll be talking on that. The OSI reference model, it was established it is an outcome, it is something which just came up from ISO actually. So first I'll talk about what exactly ISO is. ISO is established in 1947, and it is basically an organization that is that works on standardization of different products, different services across the globe. So it is basically, ISO stands for International Standard Organization, and it is a multinational body that is dedicated to world standardization for different services that we have over the globe. And ISO basically covers all aspects of, in this case when you are talking about computer networks, ISO standards covers all aspects of network communications in the OSI model. What exactly OSI is? The full form of OSI is Open System Interconnections, and it was first introduced in late 1970s. Open system interconnection, why is it so called? Why is it called open system? It is called open system because in this case the system is open for communication with other systems, and hence we are calling it as open system communication, open system interconnection. So basically ISO is the organization which deals with standardization, and one of the offshoot of this is having an OSI model that deals with computer networks for connecting different components across the computer networks through various network methodologies. So the reference model, we can say the OSI reference model, it is international standardized network architecture. As I've said, it is an abstract description for layered, as I told in the previous slide, the very concept of how exactly computer network works. To understand that very concept, we are dividing our problem domain into multiple layers, and this concept of description of layered communications across computer network and layered communications and computer network protocol designs, going for an abstract description model for layered approach, we actually do is through open system interconnections. So here exactly through OSI, we actually divide our network architecture. It is divided into 7 different layers, namely the application layer, session layer, transport, network, data link, and physical layer. These 7 different layers together comprises the OSI model. And this is basically a realization of having the layered communication protocol, layered approach in communication over networks. It is also, because we have 7 layers, it is also called as OSI 7 layer model. So we can also take a comparison of our approach in computer networks to that example of, for example, we want to see how exactly in day-to-day life, how exactly two people, let us say 2 friends, we have the sender and the receiver, they are 2 friends, let us say, and they want to communicate through postal service. So in that case, the process of sending letters from the sender to the receiver, it is a complex process involving a number of steps. So to understand that, instead of taking the entire process one by one, what we do, we divide the set of process into a number of sub-processes. And so we are saying, we are dividing, in this example, we are dividing into 3 sub-processes corresponding to 3 different layers. So the highest layer from the senders and the sender, he or she writes a letter puts it in an envelope and drops it in the mailbox. This is what happens in the first highest layer. Later on, once the letter is dropped in the mailbox, the letter is carried from the mailbox to the post office. This is what happens in the middle layer, and from the post office the letter is delivered to the carrier by the post office. Once it is being delivered, once the letter is delivered to a carrier, the parcel is then carried from the source to the destination. And what happens at the sender's end, the reverse thing happens at the receiver's end. The letter is delivered from the carrier to the post office, the letter is carried from the post office to the mailbox, and the letter is picked up and given to the receiver. So this is the set of steps that is involved when we are talking about sending a letter via postal service from one friend to the another friend. And this is something similar type something of this type happens when you are talking about communication across computer networks. So when you are talking about computer networks via OSI reference model, we are saying that we have 7 models, namely the application, presentation, session, transport, network, data link, and the physical layer. To just give a brief introduction, I will say in case of application layer, the application layer allows accesses to network resources. I will be talking more in that in the next slide. The presentation layer is meant for translation, encryption, and compression of data. The session layer is meant for establishment, management, and termination of sessions. The transport layer, it's for process to process message delivery from the source to the destination. The network layer is for moving the packets from the source to the destination, and it actually is focusing on internetworking. The data link layer, it is organizing bits into frames, and we are sending frames from via hop to hop delivery. I'll be talking more on that in the next slide. And in the physical layer, we are actually transmitting the bits over the medium through mechanical or electronic specifications. So this is again a brief layout of how the layers work. So at the highest layer we have the application, then this is how data flow, this is how we have the movement from the higher layer to the lower layer in the sender's end, and the receiver's end, it is in the reverse direction. So now let us talk about the layers in the OSI model. We will talk about the layers in the OSI model a little bit in detail. So to start with, we will first talk about a physical layer. These are the 7 layers: physical, data link layer, network layer, transport, session, presentation, and application layer. I'll talk about each of them in detail now. Let us start with the physical layer, which is at the lowest layer. It's our way, it depends on how we approach. We are starting from the physical layer, or we can also go for vice versa, that is we can start from the highest layer, which is called the application layer, but here we are starting with the physical layer. So physical layer, if you see the our OSI model, this is a slide, this thing I am including in almost all the slides so that we can relate to where exactly we are right now. So we are at the lowest layer out of the 7 layers. We are at the lowest, we are talking about the lowest level layer, the physical layer. So in the physical layer, the unit of communication is bit. So when you're talking about bit, so if you look at the physical layer, in the physical layer, data comes from the network layer. So data comes from the data. The message that is being transmitted comes from the data link layer, and after it goes from the physical layer, it is transmitted over the transmission medium and goes to the receiver's end, and at the receiver's end it then enters the physical layer, then moves on to the data link layer. So when you're talking about the physical layer, we are talking about data that is transmitted in the form of bits. So this is what the information which are in zeros and ones that has been taken care of at the physical layer. So if you are looking about the physical layer, the physical layer defines the procedures and functions that the physical devices and the interfaces have to perform for transmission to occur. And in case of physical layer, the physical layer is concerned with some of the functionalities that the physical layer is concerned is, it is dealing with the characteristics of the interfaces and the media that are concerned, that are related in physical transmission, how the bits are represented, the data rate, the number of bits that are being sent per second, the line configuration, the point-to-point or multi-point configuration, the topology, the physical topology, the transmission mode, whether you're going for simplex mode, the half duplex or the full duplex mode. These are some of the factors that we consider when you're talking about handling the physical layer. Now when you're moving to, if you look at the diagrammatic view of how exactly physical layer works, so this is a sender's end, and this is our receiver's end, and the data is being transmitted through various routers, R1, R2, R4, and so on. And as the data starts transmitting from the sender's end, the data here is in the form of bits when you are talking about physical layer. So let us say it is 0, 1, 1 or something like that, which is in bit configurations. So this is how it moves. If you just see, this is how, as it is going from link to link, this is the bit configuration, the corresponding bit configuration that is being transmitted. This is like from link 1, this is the link 1, these are the links, the corresponding bit pattern that is being transmitted, and so on. And later on, as it goes to the final destination, here the destination is the B device and the sender is the A device. And if you see that unit of transmission which we are taking care of, it is in bit patterns, that is in having combinations of zeros and ones, represented by combinations of zeros and ones. Now let us move on to the next layer, that is called the data link layer. The data link layer, in this case, unlike the physical layer where the unit of communication was in bit, here the unit of communication is in frames, and here this is the pattern, the data link, this is where the data link layer is. If you see that in the data link, if you look at the sender's end, in the data link layer, the data comes from the network layer and goes to the physical layer. From the network layer and goes to the physical layer. And if you look at the receiver's end, it goes in the reverse direction. The data comes from the physical layer and goes to the network layer. This is the data part, which we call it frames when you're dealing with data link layer, and it has, this is the header part and this is the tailor part. So when you're talking about the data link layer, if we look at the functionalities of the data link layer a little bit in more detail, the data link layer transforms the physical layer, which is a row transmission facility. It converts it into a form which is reliable, and it is responsible for node to node delivery. The data link layer basically will be concerning with framing, which is a very important part of data link layer, addressing part, the physical addressing part, the flow control, the access control, the error control. These are some of the functionalities that are performed in the data link layer. So the focus in data link layer is for moving frames from one hop to another. So let us look at the communication pattern in the data link layer. We have the sender, which is designated by system A, and the receiver, which is designated by system B. And let us look at the more detailed simulation pattern of how exactly the flow happens. Unlike if you see the previous case, in the previous case the data was in the form of bits and so on, zeros and ones. Here the data will be in the form, the unit of communication basically will not be in the form of bit, but it will be in the form of frame. If you see, the unit of communication is in the form of frame. So from the sender it goes to the first router, then from the first router goes to the second router. The path will be selected, of course, via some other layers we will be talking about later on as we move further. Then it is moving. If you see, this is the frame that is being transmitted. Then as you move on to the next router, the frame is moving. As you move on, the frame moves, and finally the frame reaches the destination. So if you compare it with the previous example, here our unit of communication is frame, and previously the unit of communication was in bits. So the data link layer, basically it is also called as a layer which deals with hop to hop delivery. So from the sender system to the receiver system, we have different routers in between, different links, and the data or the frames goes from the system to the first router, from the first router to the second router, and so on. This is the path that we trace, and hence this pattern or data link layer is also, we can also say it deals with hop to hop delivery. Our next layer is network layer. The network layer, basically in this case the unit of communication in the network layer is basically a packet. We call it as packet. So if you see, in case this is where the network layer is, this is where the network layer is. In case of network layer, the data comes from the transport layer to the network layer, and from the network layer it goes, from the transport layer it comes to the network layer, and from the network layer it goes to the data link layer. That is what happens at the sender's end, and at the receiver's end it will be vice versa, because it is coming from the physical layer to the application layer to move on in the reverse direction. So at the receiver's end, the data will move to the network, will be moving from the data link layer, and it will go to the transport layer. Now if you talk about the functionalities that the network layer is concerned with, the network layer, we can say it is responsible for source to destination delivery of a packet across multiple networks. And here the main important function that are concerned in data link layer deals with logical addressing. It deals with routing, which determines which path the data should take based on the network conditions, the priority of services, and other factors. So in this case, as I told you in the previous case, when you are talking about physical layer, the unit of transmission was bit. In case of data link layer, the unit of transmission was frame. Here in case of network layer, the unit of transmission is packet. So if you summarize this, we can say this hop to hop delivery from the sender to the receiver, from one hop to another hop, from hop, this deals with the this is dealt with by the data link layer. In case of network layer, we just focus on the source and the destination, and our focus is more from the source to the destination when you're talking about network layer. Now let us come to the transport layer. In case of transport layer, the data is being transmitted from the session layer to the transport layer at the senders, and from the transport layer it goes to the network layer. So in case if you look at the transport layer, data moves from the session layer to the transport layer, from the transport layer to the network layer. This is what happens at the senders end, and at the receivers end, the data moves from the in the reverse direction, that is from the network layer to the transport layer, and from the transport layer to the session layer. And the unit of communication in case of transport layer, we call it as segment. Now transport layer, if you look at the responsibilities or the functionalities of the transport layer is responsible for process to process delivery of the entire message. It makes sure that the data arrives without errors and in proper sequencing and in the right condition, a reliable condition which is free from errors. And the functionalities that are involved in transport layer are port addressing, segmentation, connection control, flow control. These are some of the functionalities that are concerned with in transport layer. Now if you look at the transport layer, so as I told you, in case of transport layer we are dealing with segments. So this is our sender, this is our receiver, and we have moved on to hop delivery. From hop to hop delivery we have moved on to source to destination, and here also we are no more in the hop to hop delivery. We are ordering from the source and the destination end, and our unit is the segment. So if you look at it like this, so when you're talking about network layer, in the network layer focuses is concerned with the source and the destination and the flow of packets from the source to the destination. When you're talking about transport layer, the transport layer is concerned with the processes inside the system which is dealing with the transportation of data right now in the communication platform, the process or the senders end, from the process at the senders end to the process at the receivers end. So the transport layer is basically responsible for the delivery of a message from one process to another process. So transport layer, when you are talking about transport layer, we are talking about processes at the senders and at the receivers end which are dealing with the transportation or communication of data at that particular moment. Finally, with the session layer, in this it is basically responsible for dialect control and synchronization. In case of session layer, the data comes from the presentation layer to the session layer and then goes to the transportation layer, from the presentation to the session, from the session to the transportation layer. This is what happens at the senders end, and at the receivers end, the data goes from the transport layer to the session layer and then to the presentation layer. This is what happens at the receivers end. What exactly happens in the session layer? The session layer basically is meant for handling of sessions. Basically, it allows two applications that are in different computers to open, use and close a connection called a session. The session layer is basically responsible for handling of sessions where communication can occur between the senders and the receiver system. The functions that are involved in session layer is dialog control, which is making sure that the session is established in an orderly manner. It performs name recognition and other functions. It is also meant for synchronization, so it ensuring that the session layers basically synchronization. Basically, it works when you're talking about synchronization, we are talking about both the senders and the receivers and are in sync when they are communicating data from one end to the other end. And to handle that, we have the concept of checkpoints, which are being broken through checkpoints. Basically, what we do, we break the data into smaller groups, and once we are breaking the data into smaller groups, it becomes easier for error detection. Next, we have the presentation layer. In the case of presentation layer, at the sender's end, the data comes from the application layer, goes to the presentation layer, from the presentation layer to the session layer, that is from the if this is where we are in the presentation layer. So from the, it comes from the application layer, from the to the presentation layer, from the presentation layer to the session layer. This is what happens with the senders and at the receivers, and it is in the reverse direction from the session layer, to the presentation layer, from the presentation layer to the application layer. The presentation layer, basically, if we talk a little bit more about presentation layer, it is responsible for translating, for the translation, compression and encryption of data, and it deals with the actual formatting of data. So when you are sending the data from the senders and to the receivers, and the presentation layer deals with how data is compressed to a smaller size, how the data is encrypted, how the data is represented. We, for example, this is an example of converting from EBCDIC code to ASCII code when you are talking about transmitting data. Finally, we have the application layer. The application layer, if you look at the application layer, at one end of the application layer we have the user system, and at the other end of the application layer we have the presentation layer. So at the end, at the sender's end, the data comes from the user. The data comes from enters from the user to the application layer. From the application layer it goes to the presentation layer. This is what happens at the sender's end, and at the receiver's end it will go in the reverse direction. From the presentation layer it goes to the application layer. From the application layer it moves to the users. So when you're talking about what exactly happens in the application layer, we can say this layer basically relates to the services that directly provides user interface, that because the application layer is a layer via which user interacts. So we basically focus on the services which the users are being provided through like software systems like email, database access and so on. In other language, we can also say that the application layer, it serves as a window through which applications processes can access network services, and the application layer enables the user to access the network. So we can say this layer, basically this would be the layer that a programmer uses to allow his application to access a network service, such as linking into a database. So from through the application layer, the user basically accesses the network system, or through the basically sends the data, the user gets an interface via which the user can connect with the communication system and start transmission of the data. So we can say that we can summarize and say that the application layer basically is responsible for providing services to the users. So the unit of communication, we can say, when you're talking about application, is message, because when you're talking about users, when you're sending some data from the user's point of view via email, for example, we are taking the whole thing as a totality. We are taking it into we are considering as message. So the unit of transmission, when we are talking about application layer, we call it as message. And these are some of the protocols: SMTP, Telnet, HTTP. That are some of the protocols that are dealing with this concept to handle the responsibilities of application layer. So this is how it works. Again, if you look at it, since we are talking about application layer, the application layer is talking about data in the form of message. So it is messages, and it starts from the senders and goes to the receivers end. So we are representing the message as D5 and the header of it as D5 in blank background. And this is the path that is being followed over the medium through various routers as it goes from the source A to the destination B. These are some of the if you sum now to end with this are the seven layers of OSI model, which we have right now discussed: application layer, presentation, session, transport, network, data link layer and physical layer. So application layer basically is a layer which deals with the end users. And some of the protocols in application layer are HTTP, FTP, DNS and so on. Presentation layer basically deals with, if you remember, presentation layer deals with data compression, deals with encryption, deals with transformation of data into a format which can be standardized and which can be understood across the networks through different medium. So presentation layer basically deals with syntax layer, we can say, and some of the protocols are SSL, SSH, JPG and so on. Followed by session layer. The session layer deals with synchronization and sending of data through ports. Some of the focus points where we need to stress on when you're talking about session layer are APIs, sockets, WinSock and so on. When you're talking about transport layer, it deals with end-to-end communication or end-to-end connections. Transport layer, two important protocols in transport layer are TCP and UDP, which needs thorough understanding. followed by network layer, which deals with packets. Some protocols are IP, ICMP, IPsec, and so on. Followed by data link layer, where we are dealing with frames. Focus of interest is data link layer, which is Ethernet, PPP, switch, bridge. In case of physical layer, we are talking about physical structure of this medium via which the data is being communicated. Our focus of interest are the transmission medium like fiber, wireless communication, repeaters, and so on. If you look at the devices that are used in physical layer, the repeaters and hubs are the devices that are that we look on when you're talking about physical layer, or that we use for physical layer. Bridges and switch when you're talking about data link layer, routers when you're talking about network layer, transport gateway when you're talking about transport layer, application gateway when you're talking about application layer. So this is a brief introduction to the 7 layers of OSI model, the functionalities and the role that they play for the main purpose of communicating data from the senders and to the receivers, and using a layered approach where the entire task is broken up. The entire task of transmission of data from the senders and to the receivers and is broken up into 7 sub layers, and these are the 7 sub layers. We have talked little bit or we have talked about the functionalities, the responsibilities, the roles they play, and some of the protocols that comes under this layer. Thank you for now.